नाही कशाला वाढवून घ्यायचं? ऑर्डर केलं की रोज नाहीच करणार आहे असं.
Hello, participants. We'll start in 5 minutes. So, good morning, everyone, and welcome to the third day, session one of our STTP on exploring immersive learning through AR/VR. And I feel honored to introduce today's distinguished speaker, Dr. Rajesh Kulkarni. Dr. Rajesh Kulkarni, hello, sir.
Hi.
Dr. Rajesh Kulkarni is presently working as an associate professor at Maruti Venkata Subbarao MESR Engineering College, Hyderabad. He has completed his PhD degree from Jawaharlal Nehru Technological University, Hyderabad. His area of interest are business analysis, computer organization, advanced machine learning techniques, data science, and augmented reality and virtual reality. He has been a resource person for many FDPs and was also chief coordinator for Initium 2021 conference. He has published, he has 4 papers published in SCI Index journals, 8 in Scopus Index journals, and 7 in UGC Careless journals. He has authored 9 books in the area of Python programming, blog journey, data warehousing and mining, fundamentals of computer programming, and many more. He has 11 patents, 1 copyright, 1 trademark, and 3 design patents to his credit. He has been invited as a session chair, keynote speaker, program chair for many reputed conferences and journals. And he has also served as a reviewer for 7 reputed conferences and journals. So, sir, I extend a very warm welcome from Father Conceicao Rodrigues College of Engineering. And I, Dr. Dipali Kosti, once again welcome you for this session. And sir will be discussing introduction to VR, virtual reality. And I think we should start the session. Over to you, sir.
Yeah. Uh, Thank you, college authorities. Thank you, Deshmukh Madam, Koshti Madam. And so let me just start by asking few questions to the participants. I'll be using the chat window. Hope it will work. So my first question is, how much time you spend on your mobiles daily? You can answer in the chat. I'll be waiting for the answer. My question was, how much time you spend on your mobiles daily, a rough estimate? Yeah, more responses so that I know that you are there. Okay. Even that's what the answer matches the statistics also. The statistics says that around 3 hours 50 minutes of daily usage of mobile screen is done by us users, and it sums up to around 10 years of our lifetime. So if I live for 70 years, I might have spent around 10 years on my mobile. And you can visualize this as your field of view also is restricted. Your field of view is restricted to your mobile, a restricted field of view. So, and you can, as humans, have the capability of field of view of nearly 190 degrees. So we are missing all that's happening in our ecosystem or the environment or the surroundings. So during that time of the screen time we are spending, that I remember an interesting incident also regarding this. So I had been to some tourist place in Hong Kong very long back, and guide. We are spending more time on our mobiles, taking pictures and videos, and her say was same thing. Your field of view you are restricting. You keep your open your eyes, have a look at the surroundings, enjoy the sceneries, and so on and so forth. So that's what technology has, good and bad mix. So I have one more question to you, that I'll be putting it. So how many of you used PlayStation? So I put the question in the chat window, hoping an answer in the chat window. How many of you use? Did you get the question? Okay. Anyone? Anyone? So not use, never use, I don't use. Okay. Right. Okay. So you belong to the category of people like me who are averse to this. I belong to a generation which tells all the kids, be it the undergrad or postgrad or kids, don't use your mobiles, don't play video games, don't spend much time on all those PlayStations and Nintendos and all those VR games, virtual reality games. But we also know that there is a huge crowd, even the people of, I have seen people whose ages are 30, 35, 36, 37, who are like professional players, and they live in that world of virtual reality games. They know the characters, they become the characters, they design the characters, they're part of that, and they're pretty excited about the happenings there. What new game is coming, what new version is coming, what's happening to the avatar in that game. So they may immerse their avatar in that also. So that, but I don't belong to that community, that generation. So I belong to a games खेलने video games खेलने and so on and so forth. So I have one more question. How many of you have used or bought a VR headset? I repeat the question. How many of you have used or bought a VR headset? Yeah. Okay. So you belong to my fraternity of not used a VR headset or not bought a VR headset. Welcome. So let me just ask, do you know this game, which is pretty popular? Have you heard of? Yeah, somebody said I have used it. Great, great. But there is you people are in minority. I have tried. I have tried. Okay, great. But you people are in minority, at least in this crowd today. Uh, yeah, my second next question was, I put the question as, how many of you know this Starways Galaxy Edge? How many of you know this? Should I repeat the question? My question is Starways Galaxy Edge. Okay, somebody said tried VR headset, fantastic. Okay, okay, okay. So that's what. It is supposed to be a very famous, well-known game. and played on PlayStation, something like that. So there are a few characters also. For example, I'll just put the character name in the chat window. So there is a character by name G Man. There is a character by name Arthur Ford. These are all virtual reality avatars or characters, which us, the minority, who are not exposed to this world of virtual reality, may not know. But there is a generation of, and there is a huge population which is totally immersed in this. They have their huge consoles, they have good hardware, graphic cards, VR headsets, and so on and so forth, and they're pretty. They also maybe making that their career as well as earning money through that. That also may be there. So it seems this VR world, virtual reality world, uh, has the need of virtual reality headsets. So virtual reality headsets may be there. So maybe you'll be using lenses or maybe using glasses. For example, we have heard about Apple glasses or those kind of intelligent glasses. Or in future, we may come across neuro interfaces wherein the hardware or chip may be incorporated in our body also. It is when we are started our discussion. It seems we belong, at least by looking at your responses, majority of us are belonging to a generation which are not that, or we are not that belonging to virtual reality games or virtual reality gadgets, virtual reality technology tools, kits, and so on and so forth. But it seems virtual reality usage, just as your mobile usage or any screen time usage, has many other negative aspects also, be it sickness, nausea, and other related problems also. Eyes getting sore, and so on and so forth. Uh, but it is there. Virtual reality is there. But the others, this was the flip side of the virtual reality, which we are speaking about, like the negative aspect of virtual reality. But when we speak about the positive side of virtual reality, there are hundreds of examples. Like they especially speak about usage of virtual reality in medicine, healthcare, radiology, wherein you use this immersive technologies for training the doctors, training the radiologists, and scanning the images, scanning the body parts, and playing around with them and getting more realistic results. So that may be one application kind of healthcare. And the other application which they frequently mention is education. So in education also, uh, yeah, people are responding to it, and that's fine. So education also, they say usage of VR, usage of AR, usage of MR, which is mixed, and usage of ER, which is extended reality. So all those aspects will boost the education sector, wherein people will be using a lot of 3D aspects, 2D aspects, virtual reality aspects in their learning also. So there is one talk I was listening to, and he gave a very decent example of where this VR will play a role in the real time critical situations. So we have mentioned at least two applications while talking now, that can be education, that can be healthcare, medicine, radiology, experts. Speaking about that talk example, uh, what is the job of a firefighter? What a firefighter does? Okay, so the job of a firefighter is to kill the fire, right? And to train a firefighter, every time you cannot put the house on a fire. So you can have a simulated house fire, and you can have the simulated training. So a firefighter can be trained with the help of a simulated ecosystem for firefighting. Similar things will be possible for a say for example pilot. Also, you want to learn flying aeroplane, so use a simulator. You want to learn driving, use a simulator. So it means if you look at these technologies, say for example mobiles, I still remember 1996. Till 1996 I didn't have a mobile, and very few of my known people were having mobile, and that was the era when the incoming call and the outgoing call also were charged, if I remember correctly, 32 rupees, 16 rupees, something like that. So it was out of the reach of middle class and the lower middle class, whether it is mobiles or whether it's a car. I still remember in my native place there was only one house who had a car. So the car was out of the reach of the middle class, and mobiles were out of the reach of the middle class. So now what is there? So everyone has a mobile, everyone can afford a car, and it means that mobiles have penetrated the entire population. So what the experts in virtual reality believe is that the expert in virtual reality believe that there will be a time in the near future where VR will penetrate the entire population, just as the mobiles have penetrated, because it will be there everywhere, be it education, be it training, be it medicine, be it surgeries, be it virtual meets, be it family get-togethers. Even you might have heard about 360 tours, right? So many of the websites of your colleges will be putting a 360 tour video, which gives the real feeling of the campus and so on. So it can be this 360 tour for can be for anything. Say for example, I might have missed a concert. So there might have been some singer or big singer who might have come. I might have missed this concert. So one of my colleague may be sharing that entire concert using 360 tour, and I will get immersed in that experience as if I was part of that crowd who are listening to the music and dancing and enjoying the entire thing. Same may be possible for other aspects, whether it's music, whether it's concerts of any kind. So even many more examples can be given. Say now you go to a place, we travel, right? We travel to different places, new places, and we may not know the culture of that place. We may not know the language of the place, but your VR will enable you simplify your life there. If you face any challenges or hurdles, say for example, you don't know the route, it may be keep creating the virtual road for you, and you may be walking through that. You may face a challenge like I've missed my flight. What do I do? So it may just create another flight journey for you, or so it may tell you the route for the nearest other airport or other railway through which you can overcome the missed journey. So these are all the aspects of virtual reality, which while preparing for this introductory topic, I was going through. My take on this was how do I put it? My take was let me take a research paper, let me explore some algorithm, let me explore some case study. See the typical I was trying for that typical journey of any machine learning or data science project, which happens you take the data set, design it, model it, let it recommend it, let it predict, then the performance metrics. So and that walkthrough of the paper, that's what I usually typically do in many of my talks on data science or machine learning or generative AI or explainable AI. But this seems to be a different journey, virtual reality. So just like a kid, I try to explore the basics of this through the tools, through few basic terminologies. So let me check if this will help you. I try to uh, share my screen. Give me a minute. By the way, just if anything goes wrong, right? Maybe in my PowerPoint there may be few videos, audio may not be working. Please bear with it. I'm not sure whether it will work properly or not. If it is visible, that's fine. If it is audible, that's more than fine. But this is just a basic collection of points related to introduction to virtual reality. That's what the task which was given to me. Yeah. Hope my screen is visible to you. Just please confirm in the chat window if the screen is visible to you.
Yes, sir, it's visible.
Yeah,
Can you
fantastic.
put it into slideshow mode?
Yeah, ma'am. Yeah, I'll do
Yeah,
that. Give me a minute.
yeah, sure.
If something goes wrong, do ping me. Yeah. So let us check if this video works. Yes. We'll have to wait till this. Yeah.
My name's Wayne Watts. I picked that name because it sounded like I was alter ego, like Peter Parker or Bruce Banner. But he died when I was a kid. My mom too. And I ended up here, sitting here in my tiny corner of nowhere. There's nowhere left to go. Nowhere. Except the oasis. A whole virtual universe. Around the world and back. People come to the Oasis for all the things they can do. They say, because of all the things they can be. Can you feel this? Yeah. It's the only place that feels like I mean anything. The Oasis was the brainchild of James Hadley. Oh, if you're watching this, I'm dead. I created a hidden object, an Easter egg. The first person to find the egg will inherit $500 billion and total control of the Oasis itself. Who is this person? How the hell is they? Find him. This isn't just a game. I'm talking about actual life and death stuff. The Oasis, the world's most important economic resource. It's nothing less than a war for control of the future. I only came here to escape. But I found something much bigger than just myself. Are you willing to fight?
Yeah. So This was just a trailer of a movie, and the movie name, as you can see here, the name of the movie was Ready Player One, and this movie is directed by Steven Spielberg, and it seems it has many of the components of virtual reality uh, to connect with as a beginner. Say, for example, I could see a lot of gadgets, including the intelligent headsets. Uh, as well, if you look at the plot, what it says is that uh, using the headsets, people will be uh, performing that virtual reality tour, living that life. It's more on the lines of uh, I am actually living the virtual life more than the real life, because I am actually in that movie. What happens is all the characters, they are kind of jailed. They cannot move or they cannot go anywhere. Only alternative to kind of live their life is the virtual life through the headsets they are given, and there is a virtual world created called as Oasis, and somewhere in the trailer you might have seen it's a kind of a game or a task wherein the Easter egg, whosoever gets the Easter egg, so kind of competition kind of thing. So why I'm speaking all about that was because VR is introduced pretty much in through the movies, and we get to know through these kind of examples various artifacts of VR. So if you look at the definition of VR, no? So VR stands for virtual reality, but again you have VR, then you have AR, which stands for augmented reality, then you have MR, which stands for mixed reality, then you have ER, which stands for extended reality. But one keyword which pops up continuously is immersive. So it's an immersive technology. So VR is an immersive technology. What is the simple meaning of immersive technology is uh, I am there in that virtual. I feel that I am really there in that virtual world. So that's what is the meaning of immersive. And I'll be interacting with this virtual reality world with the help of different gadgets, as we mentioned initially. That gadget, most popular gadgets seem to be the headsets which we are seeing in just now video, or they may be glasses, or they may be other gadgets, futuristic gadgets like chips on the body kind of thing. Forgive me about this. I just had copied from somewhere. This, but imagination is there, right? Okay. Now, when we speak about virtual reality, so virtual reality technologies are either immersive or non-immersive. So, and virtual reality has the combination of following three. What are they? Immersion experience, stereoscopic vision, motion capture. Just now we spoke about immersion experience, and when we spoke about immersion experience, the meaning of immersion is the user who uses the virtual reality tools gets the feeling that he is really there in that virtual world and participating in the happenings there. That's what is the meaning of immersion. Second word is stereoscopic vision. So simple meaning of stereoscopic vision is that entire film has to be created for the two eyes. So that frames have to be created twice for the left eye and the right eye. That's what is the stereoscopic vision. Then you have the motion capture. You have the motion capture. So these are the three effects in a VR as immersion, stereoscopic vision, motion capture. So the immersive experience depends on the headsets which we had just seen, which are also called as head-mounted devices. And they speak a lot about the ergonomic aspects of head-mounted devices. Also, they are ugly, they are heavy, they may create nausea, they may create sickness, and so on. But these are the devices through which we are entering the immersive world of virtual reality. Here, few the paper which I referred had mentioned this popular head-mounted devices called as Oculus Rift or HTC Vive. Uh, and they are responsible, the head-mounted devices are responsible for that impression of giving you the impression of immersive experience. So your VR headsets have sensors. They maybe have data gloves, headsets, suits, head-mounted displays. Maybe there. Your VR headsets, popular VR headsets. We had just mentioned Oculus Rift. Maybe there. HTC various versions like HTC Vive Pro, HTC Vive Cosmos, Wall Index, Windows Mixed Reality, Samsung HMD ODC Plus. So what it indicates that just as mobiles are not reachable because of their cost and all that in the initial stages, now mobiles are affordable. Similar the case with all the gadgets, including the headsets. Now they are affordable. They say. Uh, uh, so it means in future they may be much more affordable and they may become part of life. Just as now we are spending a lot of time on our mobiles, there may be a time we'll be spending maybe after few years when we look back and remember this discussion. So we may say that now we are spending around 2 3 hours on a VR headset or on our VR activities. So that is maybe the case because as an educator, you may definitely be tempted to explore VR to make it more interesting. Your class content can be made more interesting because of the challenges in education. Because now, as an educator, post COVID, I'm like, I'm the best teacher in the world. Like that was always my feeling. The people get hypnotized when I talk and when I take my lecture. But now, post COVID, the best teacher who used to make people hypnotized can't even sustain around 7 to 8 minutes of students' attention span. So that's my challenge, right? So each one of you is a good teacher like me, and each one of you may be feeling the same thing, and each one of us may try to make our content delivery better, and we may definitely explore. We are post this workshop because you may be not just basic introduction which I'll be discussing, you may be getting more nitty gritties through other experts, and you will definitely be tempted to take things forward and bring in your classroom the VR gadgets and make the things more interesting, the content delivery more interesting. That's what is affordability is speaking all about. So what they say is your head-mounted devices can be of two types. They may be standalone or they may be tethered. I just had checked for few. I'll try to open one of them to check whether they are really available in the markets and whether they are really, for example, Oculus Quest 2, because the previous Oculus they are stopped, it seems, from 2021. So this is pretty much there. I don't know, but it is visible here, and the cost is being mentioned somewhere around 30,000. So the Y Pro headset, it seems, uh, is available, but the entire kit it seems is costing around 1 lakh and so on. Because I am not part of this, I never bought this, so I can rely only on the links I am able to see. This may be the cost, this may be the entire, and this may be the genuine cost. So you can find here the Valve Index entire toolkit for VR, and its cost. shown to be costing around 166, 686 somewhere around. So I was just trying to check whether the head mounted sets in future, if my college or me want to buy and play around with what may be the costs, are they really affordable just as they are saying they are affordable? Anyways, these head mounted devices, they are supposed to be of two types, standalone and the third ones. So let us look at this tables I borrowed from a research paper. And you can see here the different types sets being shown here is Oculus Rift S, HTC Vive Pro, HTC Vive Cosmos, Valve Index, Samsung HMD ODC plus 1, 2, 3, 4, 5. So I can see here 5 categories or 5 different types of head mounted devices. 5 categories of head mounted devices I am able to see here. And let us just check at few of the things in the table being mentioned. Say for example, resolution. I can see the resolution of HTC and Samsung is better than this Oculus Rift. And the field of view of Valve Index is the best. The field of view of Valve Index is best. But if you look at compare field of view of Valve Index with the pixel density, it decreases. It means there is a inverse relationship between the field of view and the pixels per density. So it means either I'll get a better field of view or I'll get a better pixel density. And if you look at the refresh rate, you can see here Valve Index has more capabilities, like you can manually change the refresh rate from 80 to 90, 90 to 120, 120 to 144. So seems if you look at this table, and whenever the research paper was published, these 5 devices might have been contemporary devices. As you can see, many of them may not be in the market, maybe in the market. Like Oculus Rift is substituted by Oculus Quest, that too. So, but for a comparison and to understand some basic terminologies, this table will help us. Say, for example, field of view. What may be the field of view? The field of view is a kind of how far my view can go, and in the context of angle. So they say around 190 degrees. Around, so real actual human possibility is 190 degrees. So a headset, if it is as near as 190 degree, it will be performing better. It will be as comparable to the human field of view. But you can see here, among all the 5 headsets, the field of view of Valve Index is highest. So it means if I increase the field of view, I have to compromise the pixel density. If I have to increase the field of, I have to increase the display size also. That kind of relationships may also be there. Now, so say for example, you also have one aspect called as a refresh rate, right? So frames per rate, how many you see uh, old news reels, movies, you remember, na, refresh rate. And being from the electronics background, you pretty well know the meaning of this. So what they say is for these kinds of headsets in virtual reality ecosystem, the refresh rate should be around 90 hertz. So again, in that category, Valve Index is being shown to be better. And if you see Samsung HMD ODC Plus, it has something called as a anti-SDE display. Anti-SDE display. Okay. So in the next slide, we'll try to understand what an anti-SDE display may be. But in this slide, we can collect what basic terminologies we can correct is: one is field of view, the other one is refresh rate, and the other one is pixel density. And you can see the technology is used either LCD based, or it is using AMOLED based, LED based. So let us move to the next slide. And somewhere here we had mentioned field of view, and what it is saying is the meaning of field of view is it's a characteristics that determines how wide is the viewing angle of a user in a VR while wearing a headset. So what is my viewing angle? And the human average binocular FOV, it reaches up to 190 degree. So I had collected this from a paper which I was referring. Uh, so if you have more FOV, then and if it tries to match the actual FOV, the more natural the perceived image will be appearing. Okay, if I want bigger FOV, I need to increase the display size. If I increase the FOV, the pixel density will be increasing, and the quality of image overall will be. So you need a kind of a trade-off depending on what you want. And if you look at this table, we had mentioned that also, like wall index is an example where field of view was increased while pixel density was compromised, and refresh rate has a manual settings wherein you can go from 80 to 140 hertz. That's what is being mentioned here also. Wall index is demonstrating the same. It has the widest FOV. Let's not forget the meaning, long form of that, field of view. Uh, while the technology LCD and AMOLED, LCD is based on backlight with a colored mask, and AMOLED uses the organic LED basis. Now coming to the refresh rate, what is the refresh rate? What they recommend is the refresh rate should be at least 75 hertz. The refresh rate should be at least 75 hertz. And if you have low refresh rate, you will have reduced sense of presence, reduced user response, reduced performance, and you may develop VR sickness also. You may develop VR sickness, VR nausea also. So that's what is the story about refresh rate. So let us check if the refresh rate, how much it was maintained. Okay, so all the devices, the refresh rate is above 75 hertz. That's what is being mentioned. Okay. Now, whenever we are creating a VR scene, we know that it has a high computational cost. Okay, because it has to be rendered for each eye, that is stereoscope, and it has to maintain a refresh rate which should be around 75 hertz for smooth navigation. If you want to avoid, look at the last bullet point in this slide. If you want to avoid motion sickness, cyber sickness, what they say is maintain the frame rate as 90 frames per second. So maybe in future when we all explore all these devices, we may explore the negatives, flip side of that also, kind of sicknesses, nausea, and so on. I burns it. Okay. Let us go back to this table, and here somewhere in the additional feature it is mentioned as anti-SDE display. It is mentioned as anti-SDE display. Okay. Let us try to check what is mentioned as far as anti-SDE display is concerned. First, the long of SDE, screen door effect. Screen door effect. So let us try to understand by reading verbatim what is this. It's a visual anomaly, okay, uh, which we face when we use head-mounted devices. Okay, what happens? Our headsets are very close to our eyes, and when the headsets are very close to our eyes, we see the gaps between the pixels. So the comparison being made here is like we have a mesh on our door and we see the outside world. When we see the outside world through a mesh of our door, whatever feeling we get, the similar kind of feeling will be called as a screen door effect. So it means this Samsung HMD Codis C Plus is having that anti-SD display feature. So there is a small video to highlight the meaning of screen door effect. Let us go through that. Yeah, are you able to see that there is a left side? Your screen is divided into two verticals, the left part and the right part, and the left part is still kind of a meshy, and this kind of experience is called as a screen door effect. Yeah, I'll just take a pause here and I'll just let me check. Is it fine? Are you all with me? So just to check if you're all with me, I put a word in the chat window. Anybody remembers the long form of that? Put that in the chat window. Anybody remembers the long form of what I put in the chat window? I put the word FOV. I'll put it once again. Yeah, fantastic. At least one response, thankfully, and others also will respond. No issues. Please try to respond to FOV as many as possible. Try to respond to FOV. Yeah, fantastic. Fantastic. Okay. So my next question is, what is the human FOV value in angles? How many degrees? Yeah. Should I wait? You can have a guess. Mention in degrees. Field of view. Okay. So that's 190 degrees. I do it on your behalf. Okay. Somebody wrote 130. Okay. But as per the literature, it's 190. But the one device among the five in the table had that 130 degrees. So that's correct, Bhatia ji. Yeah, fantastic. Bhatia ji also says there is a horizontal and vertical view too. Fantastic. Which is 200 degrees. Okay. So Naliji 200. That's fine. That's fine. That's fine. I just wanted to check you're there or not. So one more word I'll try to check. What is SDE? What is SDE? Yeah. And just honest answer from your side. How many of you understood SDE? It can be, the answer is either yes, no, kind of. How many of you understood screen door effect? Give me a minute. I'm just trying to charge my laptop. Yeah, it's working. That's fine. Uh, Thank you. Yeah, somebody said something related to pixel clarity. Perfect, perfect. Yeah, Bhatia ji said that's a perfect answer. Image is grid-like, mesh-like, fantastic, visual blur in the sideways. All that. It's okay. It means you understood. I'll go back to my PPT. Yeah, that was the table we were referring. And now when we look back, uh, field of view is important, refresh rate is important, anti-SD display is important. That again, as we said, trade-off. You need to have your own choice. Then here we had mentioned about screen door effect. That's an anomaly. We said you get a mesh-like feeling. You can see the gaps between the pixels because your eyes are very close to the head-mounted devices. Your eyes are very close to the head-mounted devices. So let us refer to the next table. But if you see the next table and the previous table, the devices are same, the same device, Oculus, Rift, HTC Vive Pro, HTC Vive Cosmos, Valve Index, Samsung HMD Odyssey Plus. Now coming to the next table, what this table is highlighting is tracking. And in this, the type of tracking being mentioned is positional tracking. And in that also, you have inside out tracking. All of them are inside out tracking, but you also have something called as outside in tracking. In inside out tracking, you have either markerless or marker based tracking. So we need to connect with the term tracking with the next slide. We'll try to do that. What tracking does is it's a process of determining user's viewpoint position, and orientation. And what they say is there are two types of tracking. One is outside in and the other one is inside out. When we speak about outside in, there are special markers which are placed on the tracked devices. Cameras are located at fixed points of the play area. They will constantly scan the space inside it. And whenever the markers are detected, they calculate the user's position based on the coordinates received from the marker. So this is what basically outside in system are being spoken about. So just to refresh, in outside in system, you have special markers on the track devices. If you have inside out systems, users' positions are determined based on the data received from the ecosystem. And if you have inside out systems, you have subcategories called as marker based and markerless. Here I have not mentioned what marker based and markerless is. My research paper which I referred may be helping us in that. So this was about tracking. Now coming to the last, controllers. So if you look at the type of controllers, there is only one type of controller being mentioned. There is one type of controller being mentioned called as 6 DOF. Everywhere it is written as 6 DOF, 6 DOF. And this DOF stands for degree of freedom. DOF stands for degree of freedom. And you have in the headset virtual reality ecosystem, you have 3 DOF or 6 DOF. You have 3 DOF or 6 DOF. I have a video which tries to highlight the difference between this 6 degree of freedom and 3 degree of freedom. Have a keener look at this and try to understand what will be 3 DOF and what will be 6 DOF through this video.
In this video, I'll show you the difference between 3 degrees of freedom and 6 degrees of freedom. With 3 degrees of freedom, only my head can move, so I can look towards the left, rotating it, can move it up and down, as well as tilting it to the left and to the right. With 6 degrees of freedom, I can move my whole body, so I can move to the left, and I can also move to the right, forwards, backwards, up and down. This allows me to actually look around 3D objects and actually move around this virtual scene. Whereas with 3 degrees of freedom, I'm stuck in this position, my body can't move, only my head can move. So I can still look around, but I can't interact with the scene as I can with the 6 degrees. In this, for example, you see your hand controller. You can then pick up objects in 6 degrees of freedom scenes, and you can just generally interact with the scene as well.
Yeah. If you look at that word just now, which popped up on the slide, was DOF. And DOF stands for degree of freedom. And for these headsets, you could see that it was 6 DOF. And I also said that there will be something called as 3 DOF also. So it is kind of option A, option B. You have 3 DOF, 3 degree of freedom, or you have 6 degree of freedom. And while I was looking at the video, I could gauge that 6 DOF is better. I have more movement options, while in case of 3 DOF, I can only move my head where my mounted device was there, while in case of 6 DOF, I have multiple other options wherein I can get better experience. That's what the video tried to highlight, the meaning of this DOF. So let us go for the next table, and here the title for this table is being mentioned as ergonomics. And the moment we speak about ergonomics, it's pretty important. We know that ergonomic design is an aspect which will be taking care of all the aspects, including your health parameters. So, and there may be many parameters in this VR ecosystem for ergonomics, but this paper had referred one major parameter is weight, because these are head mounted devices. It means it's like a helmet, heavy weight putting on my head. So the lighter the better. The head mounted device, the lighter the better. And I could see here the head mounted devices nearly are of 800 grams or 645 grams. So they are heavy, and it means for ergonomic aspects, weight is the major parameter being considered, and the lighter the better. And if you see these 5 devices, you can see that Oculus Rift S, which is not there now in the market. So now Oculus Quest 2 is there. So as per this table, he is having the lowest weight. One confession though, the 5 devices which are mentioned, they are referred in a paper, and as per their market present condition, I am not sure, but because when I compared that, at least Oculus Rift has gone in 21 only. So it means the other options also will be having multiple new versions kind of thing. But why we use these tables is we try to connect with different aspects, like we wanted to connect with FOV, we wanted to connect with SDE, we wanted to small terminologies related to this, we try to connect with the help of this table. That was the only objective. Now there is one more terminology which we should be able to grasp. That terminology is foveated rendering. Foveated rendering. Now, when we speak about foveated rendering, so there is something called as fovea, and this fovea is the middle part of this phobia, uh, when whenever I see a long distance thing, no, so I have a peripheral vision. So some part will be the outside of the zone of the gaze of the phobia. That's what is we are trying to highlight. So when we speak about foveated rendering, na, it will be replicating what happens at a fovea. What happens at a fovea? So there are objects which are nearer to my eye. There are objects which are very far away from my eye. And as the objects are very far away from my eye, they may blur, they may not be properly visible, their quality may be reduced, and so on. So in when they render, what is the meaning of rendering? So whatever the 2D or 3D the process and giving the output of a 2D or a 3D is called as a rendering, right? So when they say foveated rendering, it should replicate the fovea only. It means which are at the peripheral vision, the rendering will be of reduced quality, reduced image quality. So thereby, when the rendering is like foveated rendering, basically we are cutting the cost, and we are reducing the rendering workload. So this is one more term which we need to add up in our today's dictionary of words related to virtual reality, be it field of view or be it SD, be it foveated rendering. Now, here there is one more classification in the slide being mentioned as far as head-mounted devices are concerned. One is being mentioned as a standalone head-mounted device. The other is being mentioned as tethered. Here, the meaning of standalone is given, so the opposite of will be true for tethered. What is a standalone HMD is all the hardware components which are required for VR will be connected to it. Okay, so there is no need to have additional external hardware virtual prototype design. So that's what is a standalone HMD is. So here also a brief description of what a standalone VR headset as compared to tethered headset consists of. So they have integrated graphic processing units which generates, renders, and visualizes three-dimensional virtual environment on the display. It can also contain embedded sensors that record the coordinates of the device. It calculates exact position and orientation in space to determine the correct user's perspective. Uh, so it means standalone devices are better as compared to tethered, and they'll be increasing the ergonomics and positively affecting the user's experience in VR. So if you look back here, this bulleted point number 2 had highlighted standalone and tethered, and the next bulleted point in the next slide highlighted what exactly is standalone VR headset as compared to tethered, and why it is better and why it is ergonomically better than the tethered one is being mentioned here. So I think I'll first play the video and then I'll ask you something.
Hey, IKEA would like everyone to know about Place, our augmented reality app. Built on Apple's new AR kit, you can easily place future-scale 3D models of IKEA furniture in your place. Scan, browse, select, move, and place. So that could mean less of this, and less of this, and probably more of this. We want to make it easier for people everywhere to imagine a better place. Share this place and this place. Try place in your place.
Yeah. So again, a question from my side in the chat window. So how many of you visited IKEA? How many of you visited IKEA? Did I pronounce it correctly? Hopefully. Yeah. Fantastic. People are loving IKEA more, though it has all that whatever is there in a shop like furnitures and all the related items. It has also has good food, it seems. Anyways, what IKEA app that IKEA Place app does is uh, check how it looks, its orientation, its location, its place, and so on, how much space it will be taking. So this and other type of shopping experience also. For example, many of the high-tech supermarkets and malls, you do your window shopping and you do your payments also through all this virtual reality experience. Even people check how the shirt or a trouser or a pant or a coat looks like uh, by virtually wearing it. So that's kind of the experience is being improved experience, user experience, be it shopping, be it buying, be it clothing, be it other aspects is being shown. So let us go back to the slide. Few applications here I mentioned. As I said, we are in education. Uh, VR is in education, in gaming, movies, disease rehabilitation, surgeries, VR labs, 3D models, virtual prototype design, virtual flight simulators. They can be substitutes for training also. They can be substitutes for training also. So again, a question. I think there's a mix of crowd here which belongs to computer science and electronics. I belong to basically computer science. I did my BTech, MTech, PhD in computer science only. So if I look at this crowd, I have a question to you guys. In your labs, have you used any kind of simulators? If yes, what are the simulators and mention their names? Any kind of simulators you use, mention their names. Be it computer science or be it electronics, anything. So, do you have a simulator for PCB design kind of thing? Any answers? Any simulators you use? Okay. I'll go back to my slide. So I have a paper downloaded related to application of virtual reality in engineering education. I have highlighted few of the points there. We can have a look at that at a later stage. But this slide basically is speaking about various applications, be it education, be it gaming, movies, be it virtual flight simulation, virtual prototype design, virtual labs, 3D models, and it can be a good substitute for training. Uh, One paper I have related to virtual reality applications in radiology. So we know that radiology has to deal with a lot of patient images to understand patient parameters. So through VR, what is possible to a radiologist is a 3D scan of tissues, organs, vessels, and other abnormalities in the human anatomy body. Okay, so even you have the possibility of a hologram being created. So I think everybody knows what a hologram is. So and that will be giving you a real world scene for a radiologist to understand the parameters of a patient. Okay, so let me just check this paper, and I had highlighted few of the things. Will try to go through that. Yeah, this was the paper, and the title of the paper was "Understanding Roles of Virtual Reality and Radiology" by these authors. And we'll just read quickly the highlighted words. And the application area is what? Radiology. So it is healthcare related. So a radiologist has to deal with what? A lot of images, right, of patient data. Okay. Uh, So a radiologist will be provided through virtual reality digital images. So which will help in intervention guidance, medical training, and teaching. So you'll be having 3D images through VR for a radiologist. He can scan various parts of the human body. So it will be helpful for diagnostic radiology. It can be helpful in creating the hologram and looking at the holograms and better understanding of the human anatomy of the patient. So basically, it gives the inside picture of the body in 3 dimensions. So this will also be used as a simulator-based training for radiologists, cardiologists, and other guided medical procedures. I'm just reading out few of the highlighted words I did. Uh, so what VR does for a radiologist is it enhances the efficiency and precision of surgical procedures. A surgeon can collaborate with colleagues from other areas to make a successful surgical plans. Okay, so it will support surgeons in performing ophthalmology, microsurgeries, and neurosurgeries, and so on. So these are a few of the benefits of virtual reality in healthcare, especially radiologies. Simulation is possible, risk is reduced, more accuracy, better learning, better treatment, inpatient data collection becomes simpler. Performing complicated medical procedures in a simplistic way is possible. So these are few of the benefits of virtual reality, which anybody can easily guess and say. Coming to the hurdles of VR in radiology, what the major hurdle they are speaking of about is the cost and the training of the workforce and the availability of content while developing the VR-based facilities and tooling. As I said, I'll just be going through the highlighted ones. Uh, Coming to the applications, virtual reality applications for radiology, there is a table here. I go back and forth. I'll go back and forth. Around 11 applications are mentioned. I'll just check. There is something called as tumor analysis. So what virtual reality will be doing is it will be helping doctors analyze the size of the tumor. Okay, so which can further be helpful for better chemotherapy. So it is used for proper analysis of the level of the tumor, which is not possible with the help of traditional imaging technologies. So there is access patient images from any angles. Radiologists can now access patient imaging in a 3D format at any angle. It provides a better understanding of the patient body parts. Then here on the seventh application, it is mentioned as cleaner picture of blood vessels. This provides an appropriate picture of blood vessels. It can be used to view inside heart vessel of the patient. Uh, it will be applicable to solve various health issues for better therapy and clinical service. So these are few of the examples, around 11 examples mentioned in this paper as far as application of virtual reality in radiology is concerned, including this medical imaging inspection. Okay. So this was a paper which highlighted virtual reality applications in radiology, healthcare. So let us go further. Coming to AR, huh? So they come in kind of you have VR and you have AR, VR, virtual reality, AR, augmented reality, you have MR. mixed reality, you have ER, extended reality. And when you speak about augmented reality, we know the meaning of augmentation, add-on. And the standard examples of this are Snapchat filters, which students use a lot, Google Lens, Google Maps, and your Apple glasses, Intel glasses, all those are the examples of augmented reality. You have product from Microsoft called as HoloLens. I have not explored that, but let us explore in future. Microsoft HoloLens is an example of mixed reality rather. And when we speak about mixed reality, here there is an example being given. There is a digital book, okay? The book is not physical. The book is physical. It is anchored to a specific location in the real world, maybe my alongside the table. If I want to read that digital book, I will be putting on my headset. I'll be picking up the book with my real hand and turn the pages with my real hand as I read. So this is what is the example of mixed reality. Fantastic example here. So there is a video for mixed reality also. Let us look at this.
Hello.
This is about the product Microsoft HoloLens.
Sir, sorry, but are you showing us a video? Hello? Hello?
Yeah, ma'am.
Yeah, sir, screen is not visible. Can you please play again?
Okay, okay.
Yeah.
Give me a minute.
Yes, sir.
I just, yeah, something went wrong. I don't know what. Sorry for that. Give me a minute. I'll share it
No,
again.
no, not a problem, sir.
Yeah. Yeah. Hopefully. Is the screen visible now?
Yeah, yes, sir. Screen is visible.
Am I audible?
Yes, yes, you're audible.
Fantastic. So maybe somewhere we lost connect.
Sir, can
Here,
you
I
play
was
that
speaking
video
about.
again?
Yeah, yeah, I'll play that video.
Yeah, just try
Don't
once.
worry. Yeah. So we are speaking about those VR applications in healthcare radiology. Then we spoke about augmented reality examples, be it Snapchat filters, Google Maps, Google Lens, Internet app, Apple AR glasses. Then we spoke about mixed reality, and I like this example, which is a very fantastic example for me. I can visualize this example. I'll repeat this example of mixed reality. I have a digital book, and I anchored that digital book in my real world, say my table on my reading table. I want to read that digital book. Remember, that book is not a physical book, that's a digital book. And I'll be putting on my VR headset. I'll be picking up the book with my real hand and I can turn the pages with my real fingers. That's fantastic, right? So, and for mixed reality, one product of Microsoft is being mentioned as HoloLens. So I'll try to play the video once again.
Yes, sir, it is visible now.
Okay, thank you. Yeah. Yeah, there is one very interesting example of virtual reality usage in healthcare, and I found it very, very interesting also. And it is mirror therapy. It is mirror therapy. Okay, I'll try to tell you first, and once we have a look at the video, then again we'll try to understand such an important utility in healthcare. Okay, you can see, let us say there is a paralytic girl visible here on the right side, right? So her left hand is paralytic, and whatever the health related problem is there is on the left hand, and her right hand is working properly, and there is a mirror. Okay, so the mi- the working this hand, which is the right hand, which is properly working, it doesn't have any health issues. The left hand is kept, the hand which is having the health related problem is kept inside the mirror, while out facing the mirror this working hand is then the movements of the right hand will create an impression in the minds of the patient that the same movement is happening with the left hand also because of the mirror. And that's kind of a therapy it's used, they say. Let us, I'll go through both the videos and you can have a look at this. Forget about the advertisement. I just, whatever video had come, I just, yeah, look at the, see, the left hand is not working and the right hand is proper. See what feeling she is getting. Okay, I'll go through this also. Similar thing. This is for pain reduction after a heart stroke or amputation. So what they say, this mirror therapy is used for paralysis, for heart stroke, for if any part of your hand or leg is amputated. Post that trauma therapy, it is used mirror therapy. Let us look at this video also.
This is what is known as mirror therapy, in which a patient moves his good hand while watching in the mirror.
See here.
This is his right hand, it's his affected hand. His affected hand in this case is his right hand as he recovers from a stroke. But what he's doing is convincing his brain it's the right hand that's moving, that's going to help with his pain.
So I like this example pretty much.
This is what is known as mirror therapy.
Then when we speak about virtual reality and the players, and the major player we know is NVIDIA, and we have NVIDIA CUDAs, we have NVIDIA GeForce graphic cards, and many more graphic cards offered by NVIDIA. For even our academic labs also, we say GPUs and NVIDIA, they are better options. Then NVIDIA has also offered Cloud XR to make extended reality a better possibility. You have OpenVR and Steam VR also as technology players. So with this, I finish this discussion, but I want to also share one PDF in education, and then I'll stop. Is it the one I use? Let me check. Yeah. This paper highlights application of virtual reality in engineering education. So I can show you if something is there. You can see here simulation happening here. Circuit, explaining the circuit design kind of thing. So there may be many other simulation aspects also. This is the paper which had a lot of examples related to that. Now I have a question to all of you. I was kind of, it was very accidental for me this session. Uh, One of my friend from Gujarat could not make it, so I had to make it, and I blindly accepted because I like interacting with people. Then I came to know that it's virtual reality. Then uh, my thing is now I am a converted virtual reality enthusiast post my session only. So hopefully, I don't know how much you explored in your colleges, being electronics or computer science guys, but I have a question. Uh, will you adopt VR in your institution, in your college? If yes, in what way? I have a question to ask to you. Please respond to that. Yeah, Bhatia ji has a question that standalone HMD. So you have two kinds of HMDs. One is a standalone HMD, the other one is a tethered HMD. Standalone basically has all the equipments kept at the place, and it doesn't have any external connective requirements. So it's kind of self-sufficient. That's what is the meaning of standalone. Yeah, a question from my side.
Participants, you can unmute yourself and you can answer. Sabi, I will allow them to
They can
answer.
answer in chat also, or they can answer by
You can
unmuting
unmute
also.
yourself and answer.
Oh, very good. Balkrishnan ji has said he has already adopted Quest 2. But where? Where you adopted that? And in what? What's the kind of utility you're doing?
Sir, you can unmute and answer. Balkrishnan, sir.
Yeah. I have another question now. How many of you are going to buy a headset, VR headset in near future? Because I am definitely planning to explore many aspects in the classroom. Okay. Madam, I'm done from my side. Supriya, madam. Hope it was okay.
Yes, sir. So this is Dipali. Actually, all the name shown is
Dipali.
Supriya. Yeah, Dipali, madam. No problem. So any other questions, participants? Any more questions? Otherwise, we'll conclude this session. Thank you, sir. Thank you. First of all, thank you very much because, as you said, we had invited some other resource person, and you agreed to, take the session on this excellent session you have taken on introduction to VR, and many new terms that you have introduced. Really, they were new for us, all the terms, and the excellent example, the videos that you have shown. So basically, the last which you showed, the mirror therapy, really excellent. So we actually, there is a lot of applications in industry, but still it is unexplored area, basically what we feel in India. So most of us would like to use this AR VR tools basically for in a classroom, as you said, for improving the education experience, learning experience. So, so thank you once again from bottom of our hearts, sir. And thank you very much for sparing time from your busy schedule. And it was, I must say, it was an excellent session, sir. Your experience is beyond our expectations and imagination, sir. So with this, we conclude this session, and the next session will be at 1:30 by Mr. Pratmesh Satardikar.
Thank you all the participants. Thank you all the hosts, and let us be in touch. Thank you all.
Yeah, sure, sir. Thank you.